Let's welcome the winner of Space Science Emerging Scientist, Dr. Hugo Pfister, to present his research on supermassive black holes and its implications.
Hello, my name is Hugo Pfister. I'm currently a postdoc between the University of Hong Kong and the Niels Bohr Institute in Denmark. I first want to thank the Y-LOT Foundation for giving me the opportunity to talk about my research that is revealing hidden black holes with luminous events. So first, let's start with what is a black hole. And we will do that by looking at the center of our Milky Way. So here you have an image, a real image, and we will describe every element in this image. So first you have the scale here. So the scale is very useful because it gives you the length of this image. And here you have about 10 light days. So a light day is a very large unit that is 3 × 10 kilometers. That is a 3 with 10 zeros after kilometers. You may have heard about the light year, which is 10 to the 13 kilometers. That is a 1 with 13 zeros kilometers. So it's a much larger unit than the light day. And these length scales are very large. So to give you an idea, the distance to the sun in this unit is 0.006 light days. So you have a very small number in this unit. And still here we are looking very far away from us at the center of the Milky Way, which is 26,000 light years from us. Still, we are able to detect all these stars in this area. And you have, when you take this image periodically every year, you have that stars, you can see the stars moving. And in particular, if you zoom in even more in the center of the Milky Way, you will see that this star is orbiting as an ellipse. Similarly to the Earth is orbiting the Sun as an ellipse. The difference here is that there is nothing that we can see in the center. But still, if you reverse engineer the physics, you can assess that there is here a massive object, which mass is around 4 million solar masses. And this is one of the best proof that there is a supermassive black hole in the center of our Milky Way. And actually, if you perform a similar analysis for other galaxies, you realize that most galaxies in our universe host a supermassive black hole. Still, it's not very well understood what are the properties of these supermassive black holes, their mass, for instance, why they are here, what are the effects on galaxies, etc. And understanding all these properties is the main topic of my research. So to do that, we first need to see black holes. And to see black holes, we need events during which these objects are very luminous. So I'm going to present you 2 phenomena during which black holes radiate a lot of energy and which I'm using to actually study these objects. The first one is when 2 black holes are merging. They emit gravitational waves, which have been predicted by Einstein in the 1910s and observed in 2015. For these observations, the group LIGO and Virgo have been awarded the Nobel Prize in 2017. By chance, there will be a lot of satellites which will be launched in the next decade to detect the mergers of these supermassive black holes, so LISA and 𝐇𝐮𝐠. So here you have a video, you see the 2 black holes orbiting each other, and they emit gravitational waves which travel through time-space. And when we are able to detect these waves, we are able to understand about the nature of the system. You see that when the 2 black holes have merged, they form a bigger black hole, and there is no more emission of gravitational waves. The other events that I'm using to study these black holes are called tidal disruption events. So tidal disruption events happen when a star gets close to a black hole and is disrupted by the tidal forces. They have been predicted by Martin Rees in the 80s and observed a few years later. Similarly to gravitational waves, it's a very hot topic, and there will be a lot of satellites and telescopes built in the next decade that will observe a lot of these events. So here you have a star, here you have a black hole, and you see that when the star gets close to the black hole, it is disrupted by the tidal forces. It results in the formation of an accretion disk and a jet, which are very powerful and emit a lot of energy. So when these events happen, there is a lot of energy that is radiated away, so we can observe the black holes, and we can use these observations to understand the properties of these objects and these systems. And this is kind of the goal of my research. So in summary, as a researcher, supermassive black holes are very fascinating objects to study because there is a lot that we don't know and there is much more to discover. But also when I'm doing outreach, supermassive black holes are fascinating objects to describe because people are usually aware of these objects when they are very fascinated by black holes in general. As I mentioned to you in my previous slide, the future of research related to black holes is very bright. There will be a lot of telescopes and satellites built to detect and understand these supermassive black holes. And as such, events promoting research in this field, such as the SciTech Pioneers Award offered by the Y-LOT Foundation, are very important, I believe, to help young scientists in pursuing their efforts. And finally, I want to thank again the Y-LOT Foundation for giving me the opportunity to talk about my research.